Hey guys, how you doing? It's Mr. Lee. Hope you're enjoying this Labor Day weekend and the extreme heat that we're experiencing. Climate change is real. Anyways, I just wanted to address a question in the discussion board. This was a question about one of the homework problems, number 36, found on page 148. So this is kind of a tricky question. It's definitely one of those thinking questions where you have to use logic and reason and figure out and some math and figure out what they're asking for. So I'll upload a picture of the question, but basically the question, it looks like this, and it's about brushing your teeth, or Ricardo brushing his teeth. It says the amount of time that Ricardo spends brushing his teeth follows a normal distribution with unknown mean and standard deviation. Ricardo spends less than 1 minute brushing his teeth about 40% of the time. He spends more than 2 minutes brushing his teeth 2% of the time. Use this information to determine the mean and standard deviation of this distribution. So this is a pretty tough question, but we have to figure out, well, what are the critical values? What are the critical values of the standard normal distribution? So we know that we're going to, for these kind of problems, we're going to do a state plan, do and conclude. But for purposes of this video, to not make it too long, I'm just going to do the actual do and conclude. Okay. All right. So we know that the normal distribution, we're going to use a normal model. So we're going to go ahead and draw the normal model. And I'm going to kind of cheat. I'm going to use the lines from the scrap paper. So there is my first normal curve, and this is the normal curve with his x's. Okay, so this is Ricardo's time brushing his teeth. Okay, so that's the title. And then down here, that's not really focused. Let's see if I can focus that. I think that's a little better. Then down here on the x-axis, this is these are the x values now. Okay, so I haven't standardized yet. So these are all x values. So x is equal to what is it equal to? Time, right? Or how long does he brush his teeth? Like how long Ricardo brushes, and it's measured in time. Okay, and time, let's time is not really a unit of measurement. Let's call that minutes. And so because we're measuring in minutes, we're not going to convert to seconds. We're just going to keep it in minutes. So you're going to have like 1 minute, 2 minute, 1.0 minute, 1.05, 1.2, that kind of thing. Okay, so let's go ahead and draw this. So this follows a normal distribution, but we don't know the mean and standard deviation, so we're just going to call those mu and sigma. So we're going to go out 1, 2, 3 sigma, 1, 2, 3, -1, -2, -3 sigma. So here's mu, and here's sigma, 2 sigma, 3 sigma, negative sigma, -2 sigma, -3 sigma. Okay, so this is the model that we're working with, an unknown mu and sigma. And now we're going to add in the information about his x values. So it says that Ricardo spends less than 1 minute brushing his teeth about 40% of the time. So less than, is that a right tail or a left tail? Well, that's going to be a left tail. Okay, and the critical value for x is 1 minute. So he spends less than 1 minute, okay, about 40% of the time. So a way to write that is that the probability that x is less than 1 is equal to 0.40. Okay, so 40% of the time he brushes his teeth for less than a minute. So where would 40% be? Well, we know that the mu, that would be 50%. That critical value is 50%. And if you remember the empirical rule, the 68, 95, 99.7, we know that this is going to be somewhere to the left of mu. It's not going to be 50%, but it's going to be, something like, I don't know, something like that. just ballpark it, it's going to be between mu and -1 sigma, right? Because of the 68, 95, 99.7 empirical rule. So let's shade the region of interest. So that is that. So this statement, okay, is represented by that green shaded region. Okay, and then let me grab a different color. Then it also says that, well, sometimes he brushes his teeth for more than 2 minutes, but that is only 2% of the time. 2% of the time. So where would I logically draw this? Just again, you can actually figure out the exact value, which we're going to do in just a moment. Well, let's just ballpark it for the sake of our sketch. Where would be 2%? Well, 3 to -3, that's 99.7. Right? So that's only 0.15%. So that's too far. Well, 2 to -2 was roughly 95. So that means we have 2.5% and 2.5% in the tails. So that means it's somewhere between 2 and 3 sigma, right? So let's just kind of ballpark it right there. So that area is represented by the statement that the probability that x is greater than 2, that equals 0.02. So it's just 2% of the time he spends more than 2 minutes brushing his teeth. Okay, and our job is to find mu and sigma. How are we going to do that? Well, we can figure out the critical values for z pretty easily. Okay, we can convert these x's into z's. We know how to do that, right? To convert a x to a z, what do? Well, that's just standardizing, right? So let's just standardize this entire distribution. Okay, and let's draw the standard normal now. Let's draw the standard normal because we know with the standard normal, we know that his mu and sigma are just going to be 0 and 1. So I'm going to draw it right below here. And I'm going to cheat again because I have this worksheet. Okay, so I'm going to try to draw it the same or roughly the same as how I drew this other one. And that does not look like a curve. It looks more like a V, but that's okay. That is okay. Okay, so now this is the standard normal. So now if we take all of his x's and we just standardize them, well, we know that this becomes 1, or 0, sorry. That becomes 1 sigma, 2 sigma, 3 sigma, -1, -2, -3, right? And so these regions of interest are still the same. So I don't know where it is. It's over here somewhere. Okay, well, this is the probability now that z is less than something. I don't know what, but I know that it's still 40% of all the data, right? And this now, boom, 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 boom. This is now the probability that z is greater than, well, 2 is an x value because it's 2 minutes, right? Well, what's the z-score that goes with 2? Well, I don't know yet. But I know that the cumulative density to the right of this is 0.02. Okay, so now to figure out, like, if you have a left tail problem where they give you the density and you need to find this critical value from the standard normal, you can simply use inverse norm. So remember I told you that we're going to use normal, CDF, and inverse norm, right? And inverse norm is kind of like normal CDF going backwards, okay? So instead of with normal CDF, you're given a critical value and you find the density underneath the curve. With inverse norm, you're given the density or the area and you find the critical value. And this is for a left tail problem. But remember that the left tail, and if we're doing a left tail and if we're doing a right tail, it's the same as doing the opposite of the left tail. So let's go ahead and find this critical value. Okay, so what is the critical value of the standard normal for which the left tail has a density of 0.4? Well, I'll just go second distribution, go to inverse norm. Okay, and there it is on my calculator already. So the total area for the left tail is 0.4, And my mu and sigma are just 0 and 1 because now I've standardized, right? And then I press enter, and there it is. So my critical value is negative 2.533471011. So this z-score right here, okay, that is negative 0.2533471011. I'm purposely not rounding here, although the calculator does at some point just truncate because it only gives you, what, 9 or 10 digits. Okay, here I can round because I'm not going to use this for any calculations, negative 0.2533. Okay, so the probability that x is less than 1 is the same as the probability on the standard normal that z is less than negative 0.2533. Now let's just do the same thing over here. Okay, but remember that inverse norm gives you a left tail, right? It gives you a left tail. So second distribution, inverse norm. Okay, and now my area under the curve is 0.02. Okay, and I am doing 0, 1. Okay, and my critical value is negative 2.0533. So if this was a left tail, I'd be at negative 2. I'd be going that way. But this is a right tail, so all I have to do is just take the opposite of that. So this critical value is at 2.053748911. Here I'm going to go ahead and just give the 4 digits. So this is 2.0537. Okay, so the probability that Ricardo spends more than 2 minutes brushing his teeth is only 2% of the time, and that corresponds to a probability that z in a standard normal is greater than 2.0537. Okay, and that's 2% of the time. So now I have my 2 critical values, which correspond to these 2 critical values, because this critical value right here is what? X equals 1. This critical value right here is x equals 2 minutes, right? 1 minute, 2 minutes. So this 1 minute corresponds to this z-score, and this 2 minutes corresponds to this z-score. So now I can just figure this out by solving a system of 2 linear equations, right? So we know, well, what's the linear equation that we're going to use? Well, we know just when we're standardizing in general, z is equal to x minus mu over sigma, right? Well, I have an x value right here and its corresponding z value, so now I have 2 variables I'm solving for, but I have a second equation over here. 2 goes in there, and this entire number, and I encourage you not to round, but use all of these digits, goes in right there. And then don't round until the end. Okay, don't round until the end. All right, so I think because you guys are pretty advanced in math, that should be a pretty simple, system of 2 linear equations where you can solve for mu and solve for sigma. And when I did that, and I did not check my math, but I got something like this. I got mu equals 1.108361333, something like that. And I got something for sigma of about 0.43344512334, something like that. So approximately 1.1084 and approximately 0.433 was what I got for mu and sigma. So going back here, okay, his normal model, okay, is approximately 1.1084, or the parameters of his normal model, and 0.4334. Okay, so this would be, mu would be 1.1084 minutes. So that's his average time that Ricardo spends brushing his teeth, is about 1 minute, or 1.1084 minutes. So a little bit longer than a minute. So a minute and 6 seconds and a little bit extra. So what would 1 sigma, 2 sigma, and 3 sigma be? Well, 1.1 plus, so that's about a minute and a half, and then that's about 1.9 minutes, and then that's about 2.3 minutes. And then likewise going back this way, this is a roughly 1.1 minutes, just doing some mental math. that's about 0.7, about 0.3, and then that's a negative, so that doesn't really exist. Okay. Okay, so hopefully that helps you. And I'm not showing you all the steps. I'm not showing you the solving two linear equations, but I think that's pretty easy math for you guys. Just substituting in the x and the z critical values into this, and then the x and the z critical values into that again, and then just solving that system. Okay, thanks guys. Hope you have a great rest of your day, rest of your weekend. And yeah, that's pretty much it for this.